Welcome to part 5 of units and measurements. So in this video I am going to talk about mass and weight, of which we know that mass and weight are two words that are used mostly interchangeably when we are talking about some kinds of the quantities. But trust me that mass and weight are two different quantities that we have as quantities, of course. Now, let me start with mass. And the good part is that this is not the first time that you're coming across with the two words or the two terms or the two quantities, mass and the weight. Now, the question is, what is the difference between mass and weight? Of course, there are so many differences that you already know, and what you know is correct from grade 8, grade 9, and other forms of, levels of education. So here, I am going to give a definition of what a mass is. Then later, I have to also give you the definition of what the weight is. Now, what is mass? So mass is, we define mass as the measure. So it's the measure of matter. The measure of matter in an object which is constant and does not depend on the location. So what this means is that when you talk about mass, you are measuring the amount of the matter in an object which is constant. So meaning mass is constant. If you have 20 kilograms here on Earth, you have 20 kg here on, let's say 2 kg here on Earth, right? On Earth. If you go on the moon, what it means is that mass is constant and it does not really depend on the location. Even on the moon, you're going to have the 2 kilograms. That's about mass. So mass, we are just measuring the amount of the matter in an object, and that the mass is constant and mass does not depend on where you are, right? So it remains constant, whether on Earth or on the moon, wherever you go, the mass is going to be, the constant value that you're going to get. That's about mass, right? So catch terms in the definition is that it's the measure of the amount of the matter that is contained in an object, and that mass does not really depend on the location, and that mass does not really change. It is constant. Now, what about the weight? Okay, what about the weight? So what is weight? So we define weight as the force. Okay, it's the force that gravity, we understand what gravity is, exerts on an object. So weight is just the force that the gravity is going to exert on an object. Okay, that is weight. And is that the difference here is that weight depends on what? On the location. So when you have weight, it in other words it means that weight keeps on varying. It will keep on changing, and that change will depend on the location. So what that means is that weight will depend on the location from and where the body is being attracted, let's say on an object. That's what it means. So for example, you're going to find that the weight on the moon is about 1/60 of the weight on Earth. Okay, it's about 1/60 of the weight on the Earth. So weight keeps on varying, because the way you're going to feel the gravity when you're on the moon and the gravity that is on the Earth, that will differ. So weight would depend, on the location where you are, so meaning it keeps on changing, unlike the mass, which is the amount of the matter that is contained in an object, and we're saying the matter does not really change and it does not depend on the location that where you are. Now work with me. If you understand mass, weight, and the volume, remember now long time ago the process of measuring mass, okay, long time ago the process, okay, before these things of SI units, and the instruments came in, there was a process these people were using to measure mass. The process of, this is oddly not now, okay, the process of measuring mass was called, or let me say is called, weighing. So this is why you find that people, they'll be talking about mass, okay, but they're using the word weigh. What was the weight of the baby? And someone will say 2 kg, but someone's talking about the weight. You understand? So long time ago, they had a system when they're talking about weighing, weighing, it means the mass. I think you've seen most of the people talking about the weight of the baby was 2 kg, 3.5 kg, and so forth. It was the old, or it is the old method that, the process that they were using to measure the mass. So those people, but that was then, not now. Okay, so sometimes they're talking about the weight, but the value they're going to talk about will be in kilograms, and we understand that kilograms is the mass. Now if you understand the meaning and the difference between weight and the mass, I have to introduce you to another quantity that is very common in chemistry, which is called volume. Okay, it is called volume. Of course, if I take you back to mass and volume, sometimes you have to talk about also the instruments that are used to measure mass and the weight. So if we talk about mass, we can talk about the balance. You have a beam balance, you have a triple balance, you have those, you understand. Electronic balance, in other words, they just say balance for mass. So use the balance, okay? The types of balances, it will depend with what you want to measure. Then if you talk about the weight, mostly they talk about what is called a spring balance. Yeah, a spring balance. In most of the cases, we normally use it when you want to measure the weight of that object that you have. Now, remember that on the weight part, remember that weight is equal to mg, the mass and the gravity, of which I'm not going to talk about this. You talk about this more in physics. Now, let me talk about volume. Okay, look at here. We all know what volume is. What is volume, by the way? Volume, we define volume as, some will say it's just a space that is occupied by an object. Okay, it's okay. And other definitions, of course, you're looking at a space that is, occupied by an object. That's volume. It's fine. And other definitions, of course, that you're going to come across with. But the fact is that I've never seen a question asking to say what is volume in chemistry. This is not, the level that is you've been asked the definitions of what, but you just have to know and understand. When we say volume, what are we talking about? We're talking about that space that, an object can occupy. Okay. Now the SI units for volume, this is what you need to really get. The SI units for volume, in most of the cases we use, it's written in cubes. Okay, it's in cubes, for example. So what I'm saying is that the SI units for volume, okay, the SI units for volume, in most of the cases, you find that it's can use meter, because you're looking at the length, it's length, okay, and in most of the cases we find that we use cubic meters when talking about the volume. But since cubic meters is kind of a bigger unit, so in chemistry we don't normally deal with the cubic meters, and so forth. Instead, we use smaller units when we're talking about volume, such as, cubic centimeters. Sometimes we talk about cubic decimeters, sometimes we talk about milliliters. So if you find these in chemistry, just know that they are talking about, the volume, okay? And you know that the volume is just that space that an object can occupy, okay? That's a volume. Now, work with me. There is something that you need to understand, students and, other people out there. When you're talking about this volume, in chemistry, at each and every topic, you'll be working with units for the volume. And it's very important that you need to know how to convey the units. Okay? For example, if I have 1 cubic centimeter, how many cubic meters do you think I have? This is very important because everything that we'll be doing ahead of us, stoichiometry, more concept, those things, gases, you really need to know how to convert from one unit into another unit, because some units we need to be like, you need to stick to a standard unity for the volume in chemistry. So you need to know how to convert. And this is what we do. This is the secret about the volume, okay? If I have 1 cubic centimeter, then I want to find out how many cubic meters are there. If you're dealing with the volume, remember I said in my first part of the video, units and measurements, I talked about the prefixes and the suffixes of where I said, what you have to do here is you say 1 cubic centimeter, you know the meaning of a cent. But this is a volume. So you say 1 times 10 to the power negative 2. You put this one in brackets. Then, since this is volume, you give out what? A 3. So this means that in 1 cubic centimeter, there is about 1 times 10 to the power negative 6 what? Cubic meters. This is very simple. You don't even have to memorize it. Just understand the meaning of a cent. Those prefixes that I gave you, they are going to help you convert any kind of whatever that they are going to give you. This is what you do. This is for volume. Again, sometimes you may be dealing with a decimeter, for example. You want to find out how many cubic meters are in a 1 cubic decimeter. So what you do, you say, okay, where there's a dec, the meaning is 1 times 10 to the power negative 1. Just put there in brackets, then you give out what? A 3. So this means that 1 cubic decimeter, there is about 1 times 10 to the power negative 3 what? Cubic meters. With these conversion factors here, you can change any kinds of the units that you have. Another concept here, when talk about the volume, okay, that you people need to really understand. Look at here. It's about the volume, isn't it? The volume, the way it works, if I have 1 liter, liter is a volume. It's equivalent to how many milliliters? 1,000 milliliters. Very important to remember. And 1 liter is equal to 1 cubic decimeter. Okay? And 1 cubic decimeter is equivalent to 1,000 cubic centimeters. So sometimes you may require you change from a centimeter to a dec, a milliliter to a liter. They will specify what you have. Very, very important to understand these things that I'm trying to show you here. And one thing is that 1 cubic centimeter is the same as what? 1 cubic decimeter. This one here. 1 milliliter is equal to 1 mil. Here. It's about volume. So whatever units are going to give you, you can convert. Now, work with me, students. If you understand volume and the units that are associated with it, now we can talk about an interesting quantity which is called density. Remember, talking about units and the measurements. So what is density? We all know that density, normally say it's the ratio of the mass of that object divide the volume. It's just the mass per unit volume that you have. Now, look at here. When you're dealing with the density, what are the units? This is a formula. What are the units? Mostly you find that it is kilogram per what? Per cubic meter. These things must go hand in hand. When you have a kg, your volume must be in cubic meters. Now, this thing here is too large to work with in chemistry, and in most of the chemical applications it's too large. So you are going to find that this density in kilogram per cubic meters, in mostly we don't use this, right? Instead we use gram per cubic centimeters, where the volume is in our cubic centimeters and our mass is in what? In grams. If that is not the case, you may find that it's grams per what? Per milliliter. Remember I said a milliliter and a cubic centimeter is the same thing. So mostly if you're working with the density, they can give you this. Then they're going to ask you to convert from here to either of the two that we have here or this one there. That's what you really need to know. Now, amazing thing here, listen. In most of the cases, I have to make these things clear to everybody out there. Density of water, look at here, the density of H2O, when the question has involved H2O and they're talking about density and the volume, students, I want to make this thing clear. There's a topic that are going to come laying in term 2, which is thermochemistry. Okay, there's a part where you have to apply this thing that I'm teaching you, units and measurements. Okay, the density for H2O, mostly it's 100, we don't even calculate, it's 100 kg per what? Per cubic meters. Now if we convert this into grams per cubic centimeter, what do we have? Look at me, look at here, look at me. Yeah, you can look at me, but look at here. If I want to convert this to grams per cubic centimeters, how do I convert? Let me show you how we convert the units. Okay, let me show you. When you're converting the units, that has to do with per, it means a fraction. So for example, I am going to start with the number that I have, 1000 kg per cubic what? Meters. Then I have to find the conversion factors. Remember, I have to convert this one into what? Into grams per cubic centimeters. So I have to find the conversion factors that are associated with the gram and a kg, then a cubic meter and a cubic centimeter. Now look at here. So let me start with a cubic. I said 1 cubic centimeter. How many 1 cubic centimeter, how many cubic meters are there? It was about 1 times 10 to the power negative, if not mistaken, negative 6 cubic what? Meters. So I am going to use it here. Now how am I going to use it? I have to make sure that this thing here is cancelled. So I am going to put this here, okay, as the numerator. That's how I'm going to use this. Now look at here. So I am going to say this is the same as 1 times a 10 to the power negative 6 cubic meters. Then here I remain with 1 cubic what? Centimeter. Feel me? So this and this is going to cancel. Then down I'm going to remain with a cent. Then here I am going to look at now with the one which is associated with a kg. You know that 1 kg is equal to, what's the meaning of kilo? 1 times 10 to the power 3 what? Grams. So I am going to put a kg has to go. So I have to put this dash here. Then I have to put a 1 kg here. Then I put 1 times 10 to the power 3 what? Grams. So that I have a kg, and this kg is going to cancel. Then if I multiply with what I am going to remain with, what do you think is the answer? Look at here. What do you think will be the answer in this case? What do you think will be the answer? The answer is going to be 1 gram per cubic what? Centimeter. So the density of water in most of the cases, you find that they are going to write as 1 gram per cubic centimeter because it comes from where I have explained. So for the density of water, we don't even really have to, calculate. Now let's move on. I have some examples with me that I want to run you through. For example, on the density, I have some examples here. If I can pick one, or I'm going to share some other examples from the tutorial sheet. Then I'm going to send them to everybody out there. Okay. Then If you understand this, we have to go to another part of the units and measurements, which is called temperature temperature scales. We are still talking about units and measurements. Now, this video is going to talk about the temperature scales, okay? So temperature is another amazing measurement that we normally have to talk about, but hold the second part of the video.